Hey folks, so I wanted to give you a brief introduction to our two CNC machines that we have here at NVD. In particular, these are CNC, so computer numerically controlled mills. So technically our laser cutter and our vinyl cutter or 3D printers are all CNC machines, but these are mills because they have end mill cutters on them. So this looks like it might be an end stock cutter, an end mill. And then if we take a look at this tinier mill here, in there, we also have a really tiny end mill. So the two mills that we have, the big one that's yellow is called a Stinger CNC, and we also have a Bantam Tools mill as well. Typically, this mill is good for like real fine milling, whether it's a circuit board or we're trying to put an inlay on a nice piece of metal. It can also do wood as well. For our larger Stinger CNC, which the Bantam mill is on, this mill can technically do metal. It could do, say, like aluminum or steel. We do have the pump controller for that. We don't traditionally cut metal on this thing, but it is for larger sheet goods. I believe we probably have a cutting area on this one of about, let's say, like a little under 24 by probably a little under 3 feet. So smaller material, some metal, mainly electronics. Bigger, thicker material, bigger than, say, the laser cutter. Mainly, let's say, for furniture, wood toys, that sort of thing. So we have two CNC mills. I will make in this video series some tutorials on how to set up and create files for the Stinger, as well as how to set up and create files for our Bantam mill. So look forward to those in coming videos.
Hello folks, so I don't know exactly where I'm going to cut this in, but I just wanted to point you to my website where I have like a brief overview of CNC milling. I've used a variety of these machines, so I like to keep notes on them. Again, for a Stinger SR23, I believe the bounds of this machine, if I'm not mistaken, are like about 2 feet by 3 feet, but well within that, just because you have to clamp stuff down. I just wanted to go over CNC Operation and then some general facts that are good to know when you get into designing for CNC. So this will probably be in the beginning of my video series, hopefully. So with CNC milling, you have the ability to cut on vectors, just like we've done in the past with laser cutting, but or even vinyl cutting. But with the CNC, you can actually tell it, hey, I want to cut on the inside, I want to cut on the outside, I want to cut on the vector, or I want to do a fill or a pocket operation is what I like to call them, just because that's what our software uses as the term. So you can kind of just see a general overview here. What I also want to inform you of is, so this is like a regular old cutter, right? An end mill cutter. There are many different types of end mills. We traditionally use square end mills. They're great for just general purpose cutting. And this is it looks like a 4-flute, so it has like 4 cutting edges. We generally only use 2 flute. That's what we have in the shop. You have ball nose mills, and we'll get into why they're super useful in a moment. Hint, 3D. Roughing, we traditionally don't use diamond, nope. Indexable face mill, we do have a face mill to clean up the spoil board where we clamp stuff down if we need to resurface that. Chamfer, V-shaped mills we do use, and later on I'll probably make a really brief video on making signs with a V-carve bit. And then threaded mill, nope, we don't need to do threads. Drill mill, occasionally we'll use if we just want to drill a hole, but sometimes we'll just use a regular end mill cutter for that. Finally, shoulder mill. This is a super nice tool to have. I believe traditionally I've only ever seen them on machines milling aluminum, so we're never going to use that. Typically, square end mill, sometimes V-carve. We'll use this guy right here, the chamfer mill, and then occasionally we'll need to use a ball nose, but we can't really even do that with what we got at the school right now. So just note, you can do different operations on some machines, and again, our machine does not do it right now, and it can, we just don't have the right software for it. That's the limitation. You can actually model stuff in 3D and then cut in 3D. And that's why the ball nose is super useful. You'll do some rough cutting with, say, the square end mill, and then you'll come back and you'll use that ball nose to get a nice profile. And traditionally when you design, you just got to realize, like, again, this is a subtractive process. If you're cutting out of a sheet of material, you have a perfect sphere, you're going to end up with a perfect sphere on one side, and then on the other side you can be rest assured you're going to have like a square, basically, because it's the bottom of the material. There are ways you can index your thing, flip it over, cut on both sides. I've done that in the past. It's a total pain, but it's possible. Again, this website, I like to just keep lists of things. These are just checklists primarily for me, but you're more than welcome to use them. It's nice to organize files. Like if you're making a file, Figma will traditionally be able to just kind of like mark stuff on Figma with the proper line color, and you don't need to use that. And then when you get into the actual machine, having a checklist here that you can go through like on your phone or on the computer, I find it super useful because I have been trained to use like a shop binder like this that has like some sort of manual in it for every little thing, and this is great to have as a resource, but traditionally just this checklist is like, okay, I've done it, it's set in stone. Like, which one do I do first, measure tool versus like zeroing? It's listed here, we know to go back to it, and it's right. So there's some extra documents here, some other things there. What I also wanted to talk about just briefly, this is a machine that we have to essentially program, even though we're not like writing code for it. We are using a program called Cut2D Pro to make the code that this machine reads. So we're creating G-code. What you should know, I have this little book here. It explains a little bit about G-code that our machine, the Stinger, uses, especially. If you wanted to say like edit G-code or write your own G-code. Again, G-code is like, oh, I need to go home now. Oh, I should be cutting, and I should be cutting along this vector, right? That's what G-code is doing. It's a set of instructions, it's code, but it's actually telling this machine how to do something in space. If you want more info on it, G-code's been around since like the 1950s. It's as old as my dad. And you can go through and see like all the different codes that are general purpose. They're pretty much the same for each machine you'd ever be on. Some machines take specific codes to do certain things, and they're a little unique, but pretty much it's going to be the same wherever you go. And again, this is what's going on behind the scenes in our laser cutter, as well as when we slice something in the future in Cura for a 3D printer. There's G-code under the hood there. So if you're interested in that, there's a really solid Wikipedia page on that. So that's a little bit about our machine, Stinger SR23. Hopefully it's not too boring, but I just wanted to go over different vectors and the different cutters, and you can do some deep diving on G-code on your own time. So take care, and we are going to get into how to design for the CNC. See you soon.